Hello everyone, in this video I'm going to explain my laboratory experiment where I find the spring constant K by using an inclined plane and a compressed spring. The main purpose of this experiment is to calculate the spring constant without directly measuring the force applied on the spring. Instead, we use the conservation of mechanical energy and observe the motion of a puck that is launched by the spring along an inclined plane. For the experimental setup, first we set up an air table to minimize the friction. At the bottom of the incline, we place the horizontal spring to find the constant K of it, and we used a small puck as our object. The goal is simple: compress the spring by a known distance, release the puck, and measure how far it travels up the incline. For each trial, I placed the puck in front of the compressed spring. Then I released the puck without adding any extra force. After it stopped at its highest point, I measured the distance as it traveled along the incline. I repeat the experiment multiple times, 3 different compression distance, recording several trials to reduce the random error. Using the energy conservation formula, I calculated the spring constant for each trial. The values of K were very consistent, with small variation caused by experimental uncertainties, such as slight angle reading or errors, ruler precision, and timing inaccuracies. When I averaged all the results, the spring constant of the spring was approximately 60. This shows that the experiment successfully demonstrated the Hooke's law and energy conservation on an inclined plane. To sum up, by converting the spring's elastic potential energy to gravitational potential energy and carefully measuring puck's motion, we were able to calculate the spring constant without directly measuring the force applied. The experiment highlights the strong connection between theoretical physics and practical measurements, and it shows how well energy conservation can be used to find other unknown physical quantities. Thank you for watching.